The broadcast is now starting. All attendees are in listen-only mode.
So, ladies and gentlemen, good afternoon and welcome to this, our latest webinar in the series of from the International Society of Chief Data Officers, supporting Chief Data Officers and future data leaders. We are very lucky today to have Dr. James Meng. I've known Dr. Meng for about 10 or 12 years now, from when he was the Chief Data Officer at the United States Veterans Agency. And I know him to be a sage talker on data matters and a wise thinker on the same. He's moved on from his time at the Veterans Agency, now where he's a senior fellow at the University of California, San Diego Supercomputer Center, as you can see. And I know that he regularly speaks and teaches on artificial intelligence and machine learning. And so I imagine that he has a lot of great info for us that he is going to, as he says, tell us about the trends in those two fields, so that we can all go from here better informed. One bit of housekeeping before I hand him over to you is that there is a box for questions. If you have questions, please put them into that area, and we will go through those at the end of Dr. Meng's presentation. Jim, over to you.
Okay, good morning. Michael asked me to offer a webinar, and I thought, what are the most important things that CDOs really should know and have not been really widely discussed, or the CDOs that may feel reluctant to get in. And that's the artificial intelligence and machine learning. There were a lot of enthusiasm, but people really felt in general that there's too much mistake. I got that impression after I've been offering this class, not specifically on AI, but on the lean big data at the UCS extension for 5 years. And all the students told me that they were really delighted to have learned the top view of what AI machine learning is, and not being intimidated by the mathematics. So what I will do is I will explain what is it, and what are the building blocks, why do we need to worry about this, and what's the historical trend. Okay, so the best definition really came out of Patrick Henry Winston. He's an MIT professor, and I happened to take his class, not to reveal my vintage, but that was 30 years ago. And fundamentally, AI, at that point, machine learning was not part of the vocabulary. It basically is a computer program, but that can carry out a simulation of the human brain. The two elements are representation of the knowledge and the translation into computer operations. Now that translation and the representation introduce incredible spectrum of a variety, but the fundamental principles are never changed. One is the the rules are consistent with the condition and actions, basically cause and the consequences. By analyzing the relationship among the conditions and actions, you can create inference net, and that will evolve into insights, which we call it intelligence. and all the net and the inference are built on logic-oriented constraint net. And those bring that constraint imposed on the individual elements, and it will also allow the computer program to figure it out, the contradictions, and then it will bring it to attention and may force the programmer to change the programming logic. So in plain language, what AI really is just a software that reads and reasons human-generated text, voice, image at scale. It allows the users to eventually understand the message contained in there and then enable automation. What do we need to worry about it? Well, I'm very sure that you know the traditional data processing is saturated, and 90% of the CDOs are dealing with structured data only. And my students told me, and they were from all over the world and all different kind of industry, is that they are still very much focused on structured data, which is okay, because even unstructured data, you still have to convert it into structured data before you can get anything out of it. But that structured data alone is no longer sufficient. Structured data will tell you what happened, but unstructured data will explain to you why it's happening. And of course, we use AI and machine learning to help us to discover things well known like a fraud, and also insight. More interesting is a needle in a haystack. Eventually, that enables us to reliably automate our process. Bear in mind the AI, or eventually self-learning and all that, eventually is to replicate what the human has asked the machine to do. So the AI will never replace the human intelligence. And just to give you one specific point is, human intelligence cannot be turned off, but and it will not be obsolete. But the AI program, you can turn it off and simply unplug. Why CDO should know this? There are three points. First one is a data science. Everybody is using that data science word. We should know that it's not just the mathematical, statistical Python programs. A large part of a data science is really management. It's really no different from managing a production line in the 70s and 80s. And then came the lean revolution, and that same process is going on at the same time here, except now we have far more help from AI and the machine learning, and also that the point I think I would like you to remember after this talk is that AI machine learning, it all evolved from a single thread, from the rules, lexical, logical, contextual to knowledge. None of them have deviated from that track. So knowing that, it can help you to discern when the marketing people come to you, wanted to buy this or buy that, and you can very easily figure out where is that on this evolution chain. Rules, lexical, logical, contextual to knowledge. And that's a rule, never change, it will never change. And that will help you to sort out things from fantasy with reality. Data quality automation needs AI machine learning because we deal with unstructured data. even the structured data can get help from AI and machine learning to sort out the inconsistencies. Enterprise need AI machine learning to stay competitive, like all this supply chain management. And also I wanted to mention DNA-based pharmaceutical research. That is a fundamental contribution to getting the vaccine completed in such a short time period. And there's no doubt about it. And you will see more and more of that will come out in later years, because right now they are all keeping it a secret. Just to give you one example for CDOs, if you still, kind of skeptical, but this was published in 2013 by Fry and Osborne from Oxford, talking about the probability of occupation automation. They put it into a spectrum and cross with the probability of computerization. And on the left are those like green, light green, and the light blue, and those are like management, computer science, and education, arts, media, and they are very hard to be automated because it really requires a lot of creativity. Far to the right, the deep red, pink, and orange service cells out of office administrative support. And they are going to be large scale automation. Does not mean they will go away, but it just the sales marketing people would leverage the automated process to gain insight and therefore do their value added parts. So what's the building block for AI machine learning? It really has two parts. So one is a knowledge representation, the other one is a translation. And all those things that you see, I divided this and make it really much easier to understand. And the knowledge representation is it's a very, very much intellectual content, and it deals with the syntax, themes, and then interaction with the world. Translation into computer operations, that's where all the rapid development and very large scale invention, discovery, and you see enormous money being made in those areas for text, imaging, and the voice. This gives you a top level kind of a picture, evolution. My belief, having the AI machine learning, is to help us to make a wise decision. So it's a data decision aid. And the vertical axis evolved from rule-based to syntactic to computer mimic a human and to big data analytics based upon human knowledge. And that evolution continues. It will continue forever. And on the horizontal axis, it evolved from the expert system, list system programming, Prolog, 1950s, 80s, to natural language processing, machine learning in 90s, and to deep learning to 2010 and plus. So I color-coded this so you can see that it's evolving from this from, and that from will never end. It will come back and iterate and make AI machine learning tools even more reliable. And this is to give you a little bit more reality. And that previous slides all, basic thinking. But this is what happened in the application trends, from understanding business phenomena to do the unstructured data integration, data transformation, to outside world data, and then use the embedded analytics. And that also follows that trend from lower left to the right, upper right. And the enablers are, number one was earlier was a pattern recognition, and then image recognition, face recognition, then speech recognition. And to the right, it becomes cognitive. So after you have done all the recognition, and you become a, I would say it's you are in a higher educated state, so you can derive the cognitive results, and you can detect the trends, the correlation, and the causal relationship. And all this are happening, and you know that, and I'm not going to waste your time talking about AlphaGo, IBM Watson. But I do wanted to share with you, what does that mean? Well, this is what you start with, and you end up with this. Now, this is a critical enabler helping all the DNA pharmaceutical research to figure out how to deal with the coronavirus vaccine. So that was kind of very quick summary of the AI. But now we are moving into machine learning. I wanted to emphasize machine learning is not AI. Machine learning is only a mathematical tool to support AI development, okay? But it's a critical arm of the AI. I will not be surprised later on you'll see some additional tools come into being to help us accomplish that. So they evolve on the vertical axis from supervised optimization to unsupervised to self-learning progressively. And the horizontal axis shows from the classification to neural network to deep learning and to cognitive self-learning. Again, it illustrates the progression, the human, whatever is generated by human, it's always along those steps. You try to figure out what are the rules, and then try to collect them and iterate, and then eventually you hope to get some intelligence. It's the needle in a haystack kind of analogy. So we started out largely probabilistic. It's all based upon the probability, figure out what's the higher probability, the classification, and minimize the cost function error. And then the neural network came out was a mimic, and this came out from the psychologists and neuroscientists. They tried to figure out a computer architecture, the algorithm architecture, mimic the human mind. And then as the computer program capability became available, from single core, double core, quadruple to 1,000 core. So you have more and more computer power, and then you can do the convolution neural network and all those fancy approaches. And then eventually to the right, you have the capability to deal with natural language processing and the natural language interfacing. And then eventually evolve into the word vector, word-to-vec, and the globe, Google globe vec. So the first wavefront was largely used the rule to come up with training to recognize handwriting. And then, National Bureau of Standards came out with the MNIST standard so that they can, and therefore later on, all the banks use that MNIST to process the checks that you authorized to pay, and so they will activate the payment, and toward the ImageNet. So in the green block, largely the machine learning was only going from n cluster to cluster. So they group things together, have a hierarchy of categories. Everything under the sun, there are just too many of them, but you can group them into on order 20 categories and then deal with each with a similar approach and the standard. The machine learning part was a brute force. It took, millions of people contributing to convert those human knowledge, different category, into something the machine can handle. And then the blue block took that, clustered the data, and process it through convolution, activation, classification, achieve the pattern recognition, and eventually talk about the intelligence car. And of course, the intelligence cars still have a way to go. And then eventually move to the machine conscience. Bear in mind, you say, oh, okay, we are in a machine consciousness stage. No, you keep on going back to the machine learning and the iterate. So this is not a single front evolution. It's a iterative process. Just to give you a few examples of the supervised learning. You try to, on the first row on the left front, you have a muffin, a cupcake, red and the blue. You're trying to figure out, how to sort them out across this butter and sugar content map. And then progressively to the right, and now you add one more, it's a scone. And then you try to have 3 groups, but you can see there's some errors. There's a red dot in the blue, there's a blue dot in the red. And then they, to the lower left is the, they call it kernel trick. It's basically going from the left 2-dimensional to 3-dimensional. You figure it out that there's one more variable that sort them out very easily when you see 3-dimension. And also the right-hand side, it's just another example. Now we move into the recognition. So as you can see that we're gonna go, from the text, image, voice, and natural language in the evolution. So this shows the image part. Started out with the handwritten, digitized signature. This helps. This is a very low tech nowadays, but it's extremely practical and useful. And then the tiny images to images of anything, and then to the fact. And there are some really strong contributors. ImageNet was led by Fan Li, a Chinese scientist who came to the United States and went to Princeton and Stanford, led an enormous effort that using 50,000 Amazon mechanical Turks. This is a human. I mean, I don't know why they call it mechanical Turk, but they literally organized those images into the world, according to the WordNet hierarchy, 22,000 categories, and just brute force labeling, and including the places like nation, waterfalls, gardens, a library, museum, in collaboration with the National Geographic and American Museum and the Natural History Society. And then further to the right, the AlexNet by Alex Krasinski and also Jeffrey Hinton and then Suskes Ever. And they took all that, again, used the convolution neural network with a 5-layer and 3 connected layer to bring all this categorize the data into intelligence, and they call it Google Net. And that, I put a social awareness, a question mark. So this is just the kind of intelligence they are deriving from the deep learning. Just to give you some example, this just shows how you recognize all the A7 progressively from more net and into fewer and high likelihood categories and solutions, and end up with the answer. Another one is the face recognition. This is very useful both for your own financial security when you go to the airport, to passport, immigration, and all that. It basically takes 5 images of the same person and digitize it, into pixel, typically a million pixels each, and then use the singular value decomposition and principal value components. This is the same things you learn in the college. Freshman linear algebra, if you remember, it was mysterious, but it's very, very practical. They took that 1 million by 5 matrix and go through the SVD PVC process. You end up with a 20 by 20. And they call this a principal value components. So Cooney will be represented by that, Obama, Thatcher, and Damon. And so you say, oh, okay, how is that singular value? PCA is really useful. Now, all the large computers, so when they do the face recognition, they don't take record your 1 million pixel. They quickly run out of the memory. They only keep the principal value component, which is 20 by 20 for each person, which becomes manageable. But you say, okay, this original picture versus what the picture represented by PCA, how do they compare? Well, the one is a reconstructed image and versus the original, and you can see the relative similarity and all that. But of course, if it's insufficient, you need to go back and like a Hillary case, that the similarity is not high enough. Now, this to the right is Professor Jonathan Cook. He posted his own picture, went through the PCA, and he did it reconstruction. He likes to find out to what degree he is similar to any of the person. So it turned out he has a high degree with the actor Damon. He was happy. Another illustration of the machine learning toward machine intelligence. The first picture detected, okay, it was a couch over playing giraffe by next to remote. It's just utterly senseless. And then after a few minutes of training, became a girl. After a few more training, it becomes a girl in red dress. And the final model is a girl in pink dress is jumping in the air. Now, what does that take to do that? It took 24 million nodes, 140 million parameters, 15 billion connections. So this is not free. It takes some persistence to get it, but it's possible. So there are ways possibly to make this far easier, and which is quantum computing, which is a course I'm going to start teaching in the fall. I'd be happy to share with you guys. Again, is to demystify the quantum computing and introduce intuitions to you, your mind, the AI machine learning is not magic. It's something, it's done by sheer clear logic and brute force computer power. Some people may not like the word brute force, but in my mind, it took 15 billion connections. It's a brute force. This is almost as difficult as the Bitcoin mining. Okay, now we move into the final topic, NLP. What is it? Well, human communicate through vision and language. Of course, the language has a lot of ambiguity, but it fundamentally is using the hierarchical structure to deliver ideas, to deliver a message. Like everything else, in that process, you start with words, a phrase, sentence, then an article, or maybe a book. Of course, artificial intelligence and machine learning, and you have to really absorb many, many books to fully understand what it really means. But it's very simple. When you've done all of that, it has only two levels. One is the syntax, the other one is the semantics. And then that's the relationship among them. Like the previous slides, the 15 billion connections. Human mind cannot do that. Maybe a genius can. The knowledge representation is largely through the word order constraints. The words were put together with some order constraints. You cannot put all the words in jumbled order. It does not make any sense. So it started from the syntax that has an order like a tree relationship, tree structure relationship. Then it's a thematic theme. It has three things in there. It's the message, the role, and the frame. So they have an order, and they have a preposition, the verbs, and the context, and the theme that will frame the facts about the way and the action will relate it to the objects. And it's all basically human logics. And the only difference now is computerized. So it helps enormously for automation. Common sense making is probably one of the most difficult things for the computer scientists. What is that common sense? It's basically knowing 30 or 60 million things about the world, but it's a human experience, but typically omitted from the social communications. This is one of the major challenge for the NLP and common sense learning, and we always show that they have really made an enormous contribution, and that took not just the computer scientists from social behavior, intuitive physics, intuitive psychology, and integrated common facts to bring it together, ultimately deliver something we call a good judgment. Okay. So why AI needs a common sense making? Because you really cannot explain. You cannot deliver the contextual common sense reasoning. Without that, we could not bring out the needle in a haystack. Of course, it's the biggest challenge is the pervasive nature of a common sense making. It's a very difficult to articulate and code in the machine. Okay, so like all the previous one, I wanted to share with you how this evolved. And the sense-making application went from the rigorous architecture to knowledge-based expert system to automation to cognitive vertically. Horizontally, it went from lexical, logical, contextual, and the knowledge. And it's really a very, very good feeling that after I studied this so many years, I found out they have never deviated from those fundamental steps. It's just like all our learning step by step. You have to be very structured and then evolve into unstructured creation. So you went from ontology, logical reasoning to the word net, verb net in green, and then the frame net and the Wikipedia, and then Yago, yet another global something. It was in Germany, and then the concept net. And now we evolve into the know-it-all, a never-ending learning, NELL. So it's largely like a university, except MCTC, it was a private company. Princeton, Berkeley, UPenn, Max Planck Institute, MIT, UW, and Carnegie Mellon University. I picked only those most critical ones, and I know there are far more university, and the university contribute in many different aspects. But it's a very simple map in my mind that you went from the rigor architect to eventually evolve into the kind of more intelligent creativity construct. And the knowledge infrastructure, I included this because there were just too many words and I didn't have enough time to go through that in a time limited event like this, but I included here so that you can read at your own leisure. But it really included the word net, frame net, concept net, and CYC. In the Wikipedia, VerbNet, DB, PDF, FreeBase, Yago. Oh, that was yet another great ontology. I forgot. Yet another great ontology for Yago. Oh, I'm sorry. I should go back. For NEL, never-ending language learner, that it's a learning 24 hours, 7 days since 10 years ago, 11 years ago. I accomplished by 2015 acquired a knowledge base of over 80 million. Confidence way to believe was a high confidence. The only point I wanted to mention this is that NEL, it may be some point where you start. You don't need to learn all the things that they have already created. For CDOs, you should just focus on learning what the NEL is delivering and leverage those to your advantage. Okay, the final area is natural language interface. So after you get all the NEL and Yago and all the things, so how you gonna link this with your activities? And so again, the reasoning principles for this is largely developed by the computational linguistics. They start from a keyword, then to pattern, to grammar rules, and then parsing the part of a speech, packing, figure out the dependence, interdependence, and consistency, and relate logically, correctly, then into the machine learning neural semantic context parsing. So you went from the parsing elements to parsing context, horizontally. Vertically, it went from simple facto to aggregation to categorize the kind of relate them, and then a negation of the things that should not be in there. And that's very important because you sort things out that's illogical or not correctly linked to complex with the joining concept and the tables. So you went from stop words to synonyms and to ontology, and then to RDF as a resource description framework, and evolved to web ontology language, OWL. And you probably have used the link open data, and that's all based upon RDF and OWL. And then further to the right, and now they can use the all these connecting graphs and similar node to infer the knowledge, or trying to bring out the knowledge. And so they direct a cyclic graph to interactively capture structure of a query intentions. So nowadays you do the query, you can very quickly get good answers. I find I was pretty amazed, quite different from 40 years. I was in the MIT library and doing some query. You have to go to the library to do the query, and that was very, very primitive. I never got the answer. But anyhow, so this is a really enormous progress. Bear in mind, NLP is on a theoretical basis. NLI is a link into the application. So just to give you a typical example how those RDF and elements are brought together, and they call them molecule templates. This was done by Germany, by a group of people in Leibniz. It shows that in DBpedia and Drug Bank and New York Times, even New York Times, are very minor in different databases. Basically, 3 large databases. They bring out the connection and relay that eventually they bring out, integrate those data into things like what I shown you before for the IBM before and then after they get a needle in a haystack. And this is another way by a Chinese group. They bring out from the sky and cloud cloud sun bright, eventually link to a airplane flying overhead in a cloudy sky with a puffy cloud, but the sun is bright and sometimes shines through the screen, cloud with a golden view, that kind of things. So the final evolution is the NLP evolved into word vector. This is based upon the mathematical observation that the word or co-occurrence counting, a very fundamental basic, how many same words counted in a sentence and related to the context. And they found out that the similar words has a close cosine similarity. I will show that to you. And basically they changed the word into a vector. Each vector, 2 vectors cross product and give you a cosine similarity, and just the dot product of 2 vectors. It's extremely efficient using the word vector versus the whole word, because there are 100 billion words. But Google has taken this effort, done a voluntary effort, convert every single word that a human knows into a word vector, and that's available for people to use. So I found this is enormously useful. Some of the most striking illustration is that word vector allows you to do the plus minus operation on a word. For example, you say Germany plus capital, that becomes Berlin. Steve Ballmer minus Microsoft plus Google becomes a Larry Page, because this is 2017. I think Google has a different CEO now. And also like Paris minus France plus Italy equal Rome. And the Sushi minus Japan plus Germany becomes Bratwurst. Okay. CEO minus copper plus gold becomes AU. That's pretty amazing. Okay, and so the word vector is the two largest contribution, enable machine learning to deal with extremely efficient small dimension word vector is on the order 100 versus a word, among a billion. So if you give an identifier, it's too big to handle. Number two, you allow this mathematical operation. So final view graph. Artificial intelligence, I did not include machine learning because machine learning is only a small current mathematical tool supporting artificial intelligence. I'm absolutely sure there will be additional new tools coming out, like a word vector and that. But they all leverage each other. Of course, it's good not to diminish machine learning. First of all, going from the operational strategic using of data, most CDOs has big difficulty doing that because they just don't have enough confidence. AI machine learning has its own risks too. There are some hypes, anxiety, expectation. And also, remember the AI machine learning evolution, it will take, probably 100 years. It's much longer than our professional years, which is only on order 40. On the other hand, the people also argue that your computer software will run into dead end sometimes. It's probably because of the program logic and also the input incompleteness. But the real intelligence does not break when you slightly change the problem. But we do have that problem, that slight change that did not give the correct answer. This was mentioned by Jeffrey Hinton, is a Royal Society's fellow, made a lot of contribution in artificial intelligence. Artificial intelligence has no empathy, but human decision has to deal with empathy. So the AI needs to be more human-centered, but the CDOs must pay some attention to learn the latest development and the leverage from them to your advantage. That's all I have. Thank you, and I have time for the questions.
James, brilliant. That was fantastic. Thank you very much indeed. We do have some questions. I won't say who the first question is from, but you do know him well. Here we go. Any recommendations on the effective way of commercializing AI data science in an enterprise setting?
Let's say that again.
Do you have any recommendations on effective ways of commercializing AI in a enterprise setting?
Well, okay, I didn't cover this one. Now, the word vector embedding. This is a group of people led by Chen Zuckerberg. She's a wife of Mark Zuckerberg. That society, in collaboration with the Princeton University, they look at 100 years of gender and ethnic stereotypes. And they sorted out the bias, women bias, and Asian bias, Islam bias, and versus the time and all that. And that the reason I show this is it answer your question depending upon your enterprise objective and what is the problem you're trying to solve. For example, if you wanted to ethnic stereotype, okay, you can use this, and you will bring out all kind of intelligence for you, And then, for example, let me give you the better example. Is something like this. Okay, you use the artificial intelligence and machine learning to try to help you describe things. So one day, it will be evolved so powerfully that remember all of the police carry the camera, and also the news reporters say if your enterprise is in broadcasting, you can use this kind of approach while you're recording by the camera of the evolution of things. The machine learning in the back end will help you to decipher what is going on and actually print out the caption to describe, okay, what's the event happening and the location, time, and also what seems to be happening. And that helps your broadcasting with a lot greater efficiency and the record of the description. So those just a couple examples.
Okay, thank you. The next question is: towards the end of the presentation, you talked about the sort of the limitations of AI and where it's going, and you mentioned its lack of empathy, and we haven't yet reached a stage where we can program high levels of understanding into these machines, and of course it's not just empathy that machines will need to be able to show to interact better with humans, but it's also the ability to apply ethics. And how do you see ethics being brought into machine learning, artificial intelligence, in a way, or in the near future, and how do you see the likelihood of success?
Okay, that's a whole bunch of questions. Let me. I think that there are two parts at least. First one is how the AI machine learning can deal with empathy, and the number two is ethics. I think they need to be addressed slightly different. On the first one, the empathy can be addressed. I believe I read a lot of articles. Fundamentally, it has to be expressed through words, tone, and also body language. So that implies for artificial intelligence to detect, the empathy and the aspect, they need both the words, the voice, and the image, so they can characterize, is that an angry motion, very rapid movement of the body, or is a nice, smooth, smiling face. It is possible, and I have seen that, but it requires data fusion from both the words, voice processing, and the body movement, that's image processing. On the ethics, you will add another dimension. On top of that, is like Chan Zuckerberg's and the Princeton's research show that they can analyze the data, and they can sort it out, the bias. And then if not solving the problem, they will at least alert the potential of ethnic violation. That's what I have. Over.
Yeah, no, I think that what you've just articulated is, yes, on some of the robots that are coming in now, some of the super duper machines, we can sort of begin to start programming empathy, but ethics is still a way away. Yes, you can try and program out things like the ability to recognize ethnic diversity, and to ensure that if you're calling up a series of pictures, that there is a proper ethnic mix. I just don't see how, in the short term, certainly, that the complexity of ethics across the sphere that they're trying to apply AI can be fully applied, accepted as at its very lowest as a sort of as a warning that to the human operator that they need to become involved.
Any more questions?
No, I just wondered what your thought was on my comeback.
Oh, well, and like you said, I mean, this is an evolution. So the degree of a success would have to be judged.
Yeah.
But that evolution is probably the longest one that would take far more than mathematics, computer science. It really is going to go back to what is a human eventually.
Okay.
And
Yeah.
that's the current track is on. Number 7, 8, 9 are all dealing with that.
Okay, super. Here's one slightly from left field after that one. Throughout the presentation, you've mentioned the number of computations that have needed to be used, just so, that millions of images cast, just so you can recognize what an Audi A7 is. How do you see the balance at the moment, given between the cost of training AI in sustainability terms, in the amount of energy that is taking, for the level of results that we're currently getting? Do you see that there is yet an effective trade-off between the amount of energy and resource consumed to what it's yet producing?
I think the machine learning, due to its incredible appetite for energy and number of nodes, eventually that's going to be taken over by quantum computing. Now, quantum computing, everybody has the impression that it needs to be in cryostat, needs to be absolutely 0-degree temperature. China's supercomputing is room temperature. They use optic. You don't need the cryostat. And in fact, I tried their 10 qubit free access computer, quantum computer at Beijing University Institute of Computer Science. And they adopt IBM's Quasum, is a quantum software approach. It was very easy. So in my view, is eventually, and also Japan, Fujitsu, came out with a small specific purpose quantum computing devices. The size is like your business card. So don't be so limited by your thinking, oh, okay, this is a huge investment. Well, it depends upon your approach. I mean, so I don't believe that the quantum computing is going to be a mission possible. What I believe is eventually the back end is going to be all quantum computing. And the reason is it's so fast. You can gazillion of input come in, you will spit it out in 2 seconds. Next. So, all that 18 billion connection I show you to process a single picture, a girl in pink jumping over, that's going to be solved very quickly, in my mind, in the future. So the quantum computing is going to address the computational power part. But the human part, the empathy, the feeling, the ethics, and that is going to take a lot more thinking. And that's really beyond the computer scientists. It's really psychologists, social scientists, experts to address that.
Fantastic. Jim, I think we're now, that's it. We have, you have managed to fill your hour. I know that we have a number of other questions that we could put to you, and we could probably keep you here for, you know, a further hour, just diving in.
Yeah, let's answer all the questions. Whoever wants to drop out, let them drop out.
No, we have things to do, and we need to move on. What I'll do, Jim, is I'll send the questions to you, and perhaps you can answer them in a thread on the isCDO website. For those that are going to, so that people can log on, review this when we post it, and see the answers to your questions.
Okay.
Brilliant. Jim, thanks very much indeed. I was expecting, you know, a high protein presentation, and you certainly achieved that. I think all of us have gone away, you know, with lots to think about, and having gained lots of knowledge. Thanks very much indeed. And I look forward to talking to you next on the next isCDO board meeting. Thank you very much.
Okay, take care.
Bye-bye.
Thank you. Thank you, everyone coming.